In this video, we're going to jump right into looking at clear text and MD5 authentication. Then we're going to take a look at conversions and optimization and scalability, so timers and things like that. And then we're going to skip filtering, that's going to be in the next video. And then we're going to take a look at default routing and the different ways you can do that, whether it's conditional or reliable and all that good stuff. And when you get into this stuff right here, it gets a little more complicated because of what the capabilities you're basically implying. So we're going to go over and we're going to configure our authentication between 26 and 27. We're first going to start off with clear text and work our way into MD5, which, by the way, MD5 is the default. So if you want to implement clear text, go right ahead. So we're going to jump right into this. We're going to go to global config, type in interface gig 1/0, because yes, folks, it is configured at the link level. And we're going to type in IP authentication. Is going to be RIP, or IP RIP authentication. And we're if I could type, and then we're going to say the mode. If you don't specify clear text, it's not going to give it to you. So text, and then we're going to enter. Then we're type in the up arrow, whack a couple times. So Control W gets rid of that. And then we're going to say keychain is going to be RIP, and we're going to say enter. So now we're going to exit out of here. We're going to type in keychain is going to be RIP. We're going to say key 1, and then our key string is going to be Cisco. Okay, so we're going to type in, do the same thing over on 27. So now we're going to do everything on 27. We're actually going to, but on 26 we're going to do a debug. And I'm going to say debug IP RIP, because it's going to break things. So we're going to wait for it to go over here for a second and see if anything happens. Okay, nothing's going on. So over here, we're going to exit out of here. We're going to type in interface gig 1/0. Type in IP RIP authentication is going to be mode is going to be text. They have to match. That doesn't change. We're going to say keychain is going to be RIP. We're going to exit out of here. We'll type in keychain RIP. We're going to say key 1. Key string is Cisco. And then we're going to go to 26, and then we're going to have stuff going back and forth here. Okay, so basically what it says right there, receive packet with text authentication Cisco. If we were to grab this guy and mosey up just a little bit here, you'll see where it says invalid authentication. Comes down here, and then all of a sudden, hey, we have a winner. And then it comes down here, and then it's going to continue to do that. But if you notice, there's our password. That's no bueno. If you don't know Spanish, that's no good. So we're going to jump over to 20. On 26, we're going to beef that up. We're going to go to global config. The nice thing about this is, as long as you call the same key string or keychain, nothing has to change. So we're going to type in interface gig 1/0. Type in IP RIP authentication is going to be mode is going to be MD5, and then we're going to say enter, and then we're going to say the keychain is going to be RIP, and then you do that, and then you go back over to, now it's going to bug out, and I'm going to wait for it to bug out so you guys can see this. So there's invalid authentication, which means that there is no password configured or authentication on the remote end configured, and then I'm waiting for it to be invalid authentication. So I think the first one we saw was up here. Oh, invalid authentication twice. Okay, so I guess I was wrong. So anyway, we're going to go to 27. We're going to go to the mode is going to be MD5. And then we're going to type in, hit the, there. And that's all we have to do. So now we go to 26. We should have, it should tell us we have a hashed password momentarily, because that was way too fast for it to have already flipped. And we received a packet with MD5 authentication. So that's authentication. Now, if it's wrong on one end, so we're going to go to 20. We're going to go to 27. We're going to type in IP RIP mode is going to be text. go to 26, and it should tell us that it's not correct. There's a question, how do you determine what type of authentication is used? Well, you can do a do show IP protocol. That should tell you. Let's see here. It should be right, or not. Hold on a second. Let me scroll up here just for a second. Okay, keychain rip. It'll tell you right at the very bottom here. It says keychain rip. This guy right here. That'll tell you that there's a keychain. So if you were to type in do show keychain, it would tell you this is Texas Cisco, and then you have to actually go to the interface level and see what's configured. So if you see a debug IP rip and that's going on there, that's going to be one of the things you need to know. So back on 27, we're going to say the mode is MD5. We go back to 26, and then here momentarily we should get a MD5 authentication, which means if we go do a do show IP route, we should have rip routes being brought in, and we're good to go. So that's how you would get that figured out. So that's going to be authentication. Very, very easy to implement. And so everything else we've got running so far is going to be going along just fine. Now, convergence timers can be configured underneath the process or at the interface level, pointing towards another RIP neighbor. So we're going to configure it under the process first. So router RIP. We're going to type in question mark, because you want to know what you have options for. So timers, and then basic. And then you're going to have 4 timers. You're going to have the update timer, you're going to have the hold down timer, you're going to have the what are they again? Oh, hold on a second. So let me do this. Do you all? Or you know what? No, let's do it on 27 first, because I don't have anything going on there. Router rip. We'll type in timers basic, and then we'll go based. Basic. You have the update timer, which is going to be normally 30 seconds. We're going to say it's 5. Now you have to be careful. If your update interval is too quickly and you've got too many RIP routes, what's going to end up happening is you won't have enough time in your update interval to send all of the updates to all of your neighbors. And remember, in most cases, it's still every 30 seconds to multicast it. So all the other RIP routes are going to receive it, or RIP routers, I should say. Now, with this, you can slow down, and we'll talk about this here in just a second. You can slow down the output rate, but still, if you have too many RIP updates, it's going to have to actually hold it for the next update interval, and you can get into a there's a term for it. I forget what they call it, but it basically you're sending too much at one time, so the process doesn't have enough time to kick it out, and then the guy coming in might be too small. So let's say you've got a big, let's say ASR 1006 at your head end, and then you're sending routes down to a little 1700 series router. 1700 series router ain't going to be able to keep up with that. Just that it's all software switched. It's not gonna. It's just gonna go. So you're not going to want to do that. So make sure you're giving your update intervals enough time to get out. Usually it only takes a couple of milliseconds, but still, if you're doing every 1 second, I mean, that's a lot of updates, and the closer your update interval is, that's the more bandwidth that's going across the wire for RIP updates. So now we have our invalid timer, which is going to be normally I think it's 180 seconds. If we go do show IP protocol, I think it'll tell us right here. Yes, it will. Okay, so invalid after 180 seconds. So we have we have the update interval is every 30 seconds. The next one's doing 13. Then we have the update. The invalid timer is 180 seconds. At that same point in time, it goes into hold down, and then after that, after 4 full minutes from the time that the last update was heard, 4 minutes later, RIP is going to say, hasta la vista, bye-bye. So we're going to do timers basic. We're going to type in 5-second update interval. We're going to say the invalid timer is going to be, I usually say 3 times that. We're going to go 2 because we're in a lab environment. The hold down timer is going to be 15, and we're going to say the flush timer is 20. So 5, 10, 15, 20. And then we hit enter. Now this will not break the writing adjacency. The reason for that is this is not a IP protocol. RIP uses UDP port 520 for its updates. Now, what's going to end up happening here is we're going to get updates every few seconds. So if we were to jump out of here and do a show IP route, we should not receive. It should not take more than. Let's do a U all here. U all. So every 5 seconds, it should not go past. This timer right here should never go past 4. See that? Every few seconds, the 4th, and then it goes back to 1. So that's what we're talking about. If a route went past 5, probably something's going on in the network, and you need to be checking it out. Now, how would you know if something was happening? Well, one good way to determine that is I like to just the core routers, and as long as you don't just arbitrarily turn the command on, what I actually usually do is I have Debug Ip Routing enabled on just the core devices. Now, what this does is it will track and debug IP route profile. What those two commands will do, and we'll see these here in just a second. What these two commands do is any routing update changes. So the Debug Ip Routing is going to be a live debug, and usually I'm piping that out to a syslog server, or I'm kicking up an SNMP trap saying, hey, this went wrong at this time, this route came in, maybe it's a route flag, maybe it was injected, who knows? And then you can start exploring out from the network. Okay, what happened? Oh, you had a network event there, somebody, unplugged this cable, plugged that cable back in, and route was learned again. No big deal. That type of stuff. So you're able to kind of have an indirect monitoring system inside your routers, inside your devices. Now, the other one is setting up IP route profile, which the first one is debug IP route, or debug IP routing. That's this command. That's going to show you a debug as long as you're debugging to the console, or usually I do it to the log or to an off-device server, and that way here any updates, changes, I'm going to know about it. The other one is going to be config T and type in IP route, and then you have this little fancy command right there in the middle that says profile. Now by doing this, if we do a show IP route profile, what that's going to do is over a period of time, it's going to show you what the interval is. So it's going to be checking frequency and changes in a 5-second sampling interval. How many changes per 5 seconds? So if you have 0 changes, so we had just 1 change. Actually, we had in the change interval 0, we had a forward path change, a prefix added, a next hop changed, a path count changed, and then we had a prefix refresh. Now, if we keep looking at this, that prefix refresh is going to keep happening. Why is that? Because we're running RIP. Every 5 seconds, we're going to be getting a routing update. Now, as long as these numbers stay right here, you're fine. Because this is happening inside of the first update interval. If this was to change and start creeping up higher towards this guy, or even way down here, then you got a major problem. That's telling you that you have routes that are just your routers are being flooded with routing updates, and then after a period of time they're being flushed right back out, and you got to figure out what's going on. Maybe you have a rogue device in the network. It could be a lot of things. So as long as your update profile is in the first interval, and here it's going to start climbing. Now this interval, it's going to keep climbing over a period of time, so you have to take this with a grain of salt, depending on the routing protocol you're working with. Because we're running RIP, this is going to increase in numbers over and over and over again. So there's that. Now I did mention I was going to show you guys another trick. Excuse me. Go into router RIP, and you get all these other fancy commands. You have the output delay. So the interpacket delay for RIP updates. So we're going to type in output delay, and you can specify in milliseconds how big of a gap per packet you send. So like I mentioned a few minutes ago when I was talking about if your update timer is really short and you got to send a lot of RIP updates, it might be a benefit to send a little bit of a buffer between each update. So that's just, and notice it says interpacket, which means interpacket means you're going to send one packet, wait 50 more milliseconds on the next packet. and then wait 50 more milliseconds to the next packet, or whatever your interval is. It's between 8 and 50 milliseconds. Use your best judgment. So there's that. Triggered updates I can't show you because I don't have the capability. Now you can go to the address family and get specific in here, but the address family, we're always going to be using IPv4 here. So let's say, for instance, we were to type in address family and you type in IPv4, and then you were to type in unicast and hit enter and go here. Same crap. It really is. I mean, there's not. You just lose the auto summary or the address family capability. All the commands are the same. I never go into AF mode. It's the same stuff. The only time it might be a little bit different is if you're using with IPv6 RIP, and then you're going to go in there and you're going to be dealing with RIP-NG. You literally just enable it. You don't even have to go turn on the global process. All you have to do to that is go underneath the link level and type in IP RIP and then the RIP named process, which usually can be whatever CCIE test, woohoo if you want to, and then hit enable. It's going to turn the process on. That interface automatically turn the global process on, and then you would go back to the global process to do like redistribution and then do any of these little hinky commands. We'll talk about that more coming up later, but it's really, really straightforward. So that's convergence timers. This maximum pass, let's show you that real quick, and then the input queue. So the input queue is going to be how many packets deep. So input queue is specified input queue depth. So in this case, that's going to be input queue, I believe, is routes coming into the router. And then the maximum paths is going to be how many maximum paths you want to go. I believe if we do a do show IP protocol, it tells you maximum path is 4 right here. So if you want to add that up to say 32, if you have got 32 interfaces, be my guest. Maximum path 32. It's up to you on how you want to do that. I don't think it's really that necessary, but hey, to each their own. Now, I'm about 17 minutes in, so what I'm going to jump down here is I'm going to do the default routing setup, just so you guys can see how that works. Now, the default routing is actually kind of interesting in how RIP does it. And actually, all the major IGPs do it. EIGRP, RIP, OSPF, ODR. We're not going to cover our ODR in here simply for the fact that you may or may not run CDP, which it needs CDP to run. And ODR, if you're not familiar with that, it literally is just one command, ODR, router ODR. And you turn that on, and then what it does is it advertises routing updates for the entire network. Now, do what you want with that. It's got the same adjustment capabilities as most other protocols. You can go in there and actually, let me just show you that real quick since I'm talking about it. Router ODR, hit enter, and then you have these options. So you can do a passive interface, this, that, and the other. Very, very simple to do. But see, the thing is you have to be running a Cisco device because it has to run CDP. So type in no router ODR. So that's all there is to that. So what I'm going to do is on 27, because right now 26, if we type a do show IP route, we have just the 10 network coming in, right? Well, what if I want to be even more granular than that? Let's say I want to add no RIP routes except for a default. Well, here's where you're going to get to do that. On 27, we're going to do this. We're going to say, oh, I forgot to mention, flip back over here. On 26, if you were to go to interface gig 1/0 and type in IP RIP and go question mark, and that top command, which is advertise, if you were to type in advertise, you can modify the interval seconds you do this. So you can say 3 question mark and hit enter. So that's every 3 seconds you're going to send a RIP update out, and that is going to override the global process because of the fact that anything interface level is going to be more specific to the protocol to advertisement. So anything interface level is going to be overriding the global process. So if you want to modify, if it tells you to set the update rate to be 3 seconds, but don't do this under the process, well, you know where to go now. So there's that. I'll just hit enter just because it can. And then we're going to go to 27. The first thing I'm going to do is I'm going to type in default and question mark. We have a couple options here. We have default and default what? Well, if you type in default anything here, this is going to return it back to its default values when you turn router RIP on. So if you type in default auto summary, it's going to turn auto summary back on. If you went to version 2, it's going to flip it back to version 1, so on and so forth. So it's going to return it back to whatever you had it before you made any modifications. So there's that, and then we're going to also do question mark. We have default information. Default information is how you would be IN is how you would originate a default route. So we're going to type in originate, and then we're going to do a question mark at the end here, and we have this fancy little thing called a route map. We'll talk about that here in just a minute. But if I was to hit enter and go to router 26 and do the show IP route, now we have a default route. Now I can do this, and then I can do a clear IP route star, and then momentarily. Okay, so we're going to get both routes. So this we can have a default route, or we can actually get rid of this route by taking the summary out, because we have the summary underneath the interface. So if I was to go in there and eliminate the summary, that would get rid of this route. We'd only have a default. Now this is what you would see if you were doing a stub route in OSPF, where you'd see only a default route, or sorry, if you did a stub no summary, you'd see that. So now that's a default route, real simple. One command, default information originate. Now this conditional default routing and this reliable conditional default routing, a little more complicated. So first one we're going to look at is conditional default routing. So we're going to exit out of here, and the first thing we have to do is we have to set up a way of tracking something. So right now we don't have anything going on in the network. So what I'm going to do is I am going to, and this works really well if you've already got a route in the table going somewhere else. So what I'm going to do is I'm just going to point a static route to, I'm going to type in IP route, and I'm going to point it to, what's the address, 2714 to get. I'm going to type in 0.0.0.0, so I'm going to set up a default route on 27, 0.0.0.0 to, was it 27.14.0.14. So that's going to be our next hop. So now if we were to do a do show IP route, now we have a default route pointing there, and then we're advertising a default route to 26. So we're the next hop for them, right? That's us. That's our address. We're the next hop. So 27 is doing that. All right. So I had that. I have that route in there. Now what I'm going to do is I'm actually going to go to for the conditional route. You have to go in and you have to, as long as this route, I should say, as long as this route is in the routing table, the default route to router 26 will be advertised. Now, this is not reliable conditional default routing. This is just conditional default routing. You're relying your default routing based on a condition that a route is in the routing table. So now we're going to type in route dash map. Yeah, hold on a second. We're going to type in IP prefix list, and we're going to say default and sequence 10 and a permit. Permit, and we're going to say the default route is going to be 0.0.0.0/0. Okay, that's what we're advertising. We can get more specific if we wanted to, but we're not going to deal with that right now. So that's the default route. We're matching this route, which is the default route we just configured. Then we're going to go up to we type in route dash map, and we're going to say condition, and then by default it's permit and 10. And we're going to say match IP address in prefix list default. And then we're going to go to router rip, and we're going to, that default information word we just used just a minute ago, we're going to go up here and we're going to, this route map, we're going to tack this on. We're going to say the route map is default. No. Condition. We're going to enter that. Now, what's happening is the logic behind this is actually very simple. We're going to do a show run pipe include prefix route dash map pipe IP route IP route pipe default. Alright, so the way this works is we have a default route. So this is going from, actually I should have put this in a little bit different. So actually let's whack this type in route, but I want to go down here and I want to type in default pipe. There we go. I want to reorder it. Alright, so we have the default route. We have the default route, the prefix list, the route map, and the IP route. So basically, what we've done is actually no, I had it right the first time. So sorry, I want to make sure you guys follow along with this. So whack all this stuff out. So we're going to type include IP route pipe prefix list prefix pipe route dash map pipe default. Okay, so we should get the same output. Okay, so basically, done. Okay, so now, starting from left to right, top down. So we have IP route. We have the default route pointing out to router 14. What we've done with the prefix list is we said in this prefix list we want to track this route right here, which is going to be pointing to this guy right here. Then we're created a route map that says I want to match the default route, which happens to be the prefix list that's calling the default route we advertise. Then we go to default, and I should have said default dash information. Actually, type it right. Default dash information. That should get it. There it is. So we created the default route to 14. We created the prefix list to track it. We created the route map to have our map from the prefix list to the default route. So we said match the default route, which happens to be the prefix calling the default route, and then we tack that onto this guy. Now, since we've already mapped this, so 26 has got this route. So I'll do a quick update. We've got this route in here. Now, if we go to 27 and we come up here and we type in no, and we wax this guy out, that goes away. 26, we take a look at this, so does our default route. Now, that's what they call conditional default routing. Your default routing based on the condition that that default route is in the routing table of the upstream device. Now, we could take this a step farther if we wanted to, and we can go back to 27, and we're going to say Control A and get that out of there. Hit the up arrow, go back to this guy, and do 26, and there it's back again. So that means the default route is working. Now what we're going to do is we're going to take this a step farther. What we're going to do now is we're going to track the reachability to this guy. So let's say, for instance, you're doing some tracking to make sure the route's there. This is where you take it a step farther with the reliability factor. So we're typing IP SLA 1, and we're going to say enter, and we're going to say we want to do an ICMP echo, and we're going to the address we want to ping is this guy. That's what we want to ping. Okay. Then we can do some other things like we want to set the frequency. I think there's defaults for this frequency, but let me just type frequency is going to be every 2 seconds. Every 2 seconds, and then so there is defaults. So I should be fine there. So let's do a do show run pipe section SLA. I think it should automatically have defaults. Show run all. Yeah, it does. So it does a threshold of 5,000, frequency of once a minute, and then a timeout of 5,000. So if you wanted to increase the frequency, it has to be higher than or equal to 5,000. There's a question: how did I get that? If you do a do show run all for a particular piece, that's going to show you everything there is to know about that command, including its default values, which is not normally shown in the running config. So we did that. So that's going to do it. But I want to do the IPSLA, ISLA, and I want to do the back to that address. Do that SCP echo. Okay, we're already there. So what I'm going to do is it the frequency? Yeah, the frequency. I want to do the frequency is going to be 10 seconds. Okay, so I want to make it a little quicker. Do the show run all again, and we should see that changes to be 10 seconds. So now what we're going to do is we're going to exit out here once, type in IP SLA and then question mark. We want to schedule this, and we want to entry number 1, and then we're going to say the start time is now, and the lifetime is going to be forever. So we never want it to stop tracking it. So now what we do, now that we're doing that, we do a do show IP SLA statistic. It's okay, which means it can successfully ping. So if we were to type in do ping 27.14.0.14, we can reach it, which means that if we can ping it, so can the SLA instance. Now we're going to type in track. We're going to say track object 1, and we're going to track an IP protocol that's going to be an SLA instance, so a service level agreement SLA instance. And then what is the entry number for that guy? Well, it's going to be 1. And then we're going to hit question mark, and then we could do reachability, we could do state. We're just going to hit enter, and then we're going to say what we want to do. Well, we're not going to do anything with it because it's just the default values. So we're going to do this. Now what we're going to do is we're going to go back to router RIP, and then we're going to type in that default information rate, default information originate route map, and then we had condition, and then we condition, and I believe there's no track. Oh, you know what? We put on the static route. That's it. Exit out of here. Take that IP route. Do show run pipe include IP route. We have to actually tack it onto the routing instance. So we'll type in IP, or just copy and paste it, and then we do a track, and then the object number is 1. Alright, so now we've done that. So now we're going to jump out of here, and we're going to say show run pipe section, include track pipe IP SLA pipe IP route pipe. And there's a question: what do I have to do? The no spaces? Yeah, because they're regular expressions, so you have to type them in as they would be. IP route, we're going to type in route dash map and prefix list and pipe default information, and hit enter. That should give us a pretty good kick out of what we got going on here. So the command is, we went in and we created a default route. Actually, I can go to config and pull this guy out. So basically now is we have the default route that we punched in there. We tacked on the tracking object by setting up the SLA instance to track the IP address of this guy. And now if we were to type in show IP SLA stat, we can get there. If we go to show track 1, we can get there. And if we look at show IP route, we have it. Now if we go to router 14 and we type in config t interface fast2/0, which is that address, so we type in shutdown, we go back to 26 or 27, where'd it go? 27. Now it shows that it's down, and do a show IP route. It pulls the route out of this guy. Go to 26, the route is now gone. So it allows you to track multiple pieces to it and keep an idea of where things are going in your network. So it's a reliability factor. So now if I was to do a debug IP routing and go to 14 again and type in no shut and go to 27 and do show IP route, as soon as the connection comes up, actually let's wait for the SLA instance to kick in, because as soon as the interface comes up, the SLA instance should tell us that it could reach it any moment now. Okay, there it goes. The SLA instance is there. So we have the route in our routing table. Now we're going to jump down to 26, and we had a debug IP route. We're debug IP routing, and so we received the default route in from there. So if we do a show IP route, now the default route is back. So we're going to type in you all there. So that's how you would do that. So it's pretty straightforward. It's just that some protocols do allow you to track the object against the default route, but I think it's better to track the route you're actually tracking. And what I mean by that is, if you're tracking a null route, and now you can null route this, you can be tracking an object. I guess it just depends on your situation, but to make a very real world, I actually just set this up not too long ago with a client, and they were complaining that they never knew when the default route would go away, and it would still be advertising. They would be blackholing traffic, and it would never go anywhere. And I'm like, they had no idea. So I was like, well, what grade equipment are you working with? They said, well, we got they call it a cheap Cisco router. It's pretty much the same thing I'm running here at home. I have a 3725. I was like, well, why don't we just implement some reliability? And he goes, you can do that? I said, yeah, absolutely. And he's just like, well, set it up, man. So it took me about 20 minutes to do what I just did, and as I had to find out what IP addresses he had and stuff like that, and I said, now if it goes down, this should pull that, that'll do this, this, and that. And he goes, it was too much information at one time for him. I got it because I showed you guys how to do it, but it's a matter of just knowing what to put where. So it's actually kind of a cool feature. So that's it in this video. The next video we're going to take a look at some of the filtering options that are out there for us and see exactly how they work, and go from there. So I hope this has been informative for you, and I'd like to thank you for viewing.